What we do here is we study lithium-ion batteries, how they interact during the normal performance, but also when some safety event happens. This is a fresh new cell. It looks fine. We have the terminals, as I show you. Everything looks uniform. Once that we start cycling the cell, what it happens is the electrodes start degrading, and after some time, the interaction between electrolyte and electrodes may lead to some condition like this. Still, the cell can be used, but we want to study how safe it is if we keep using it. Now, let's assume that we're using our charger, and for some reason, the cell keeps charging. After it's fully charged, what it could happen is the cell could reach this condition. As you compare your fresh cell, which is this one, with this one, there is a huge difference. This is a non-safe condition. At some point, it can catch fire. And what we want to study is what happened with each of the electrodes that we have inside. Now, this is a single cell. Let me show you what happened with something bigger. We have a module. It contains, in this case, is 24 cells. And then we run one test, what we call overcharge. I cannot even take out the cells, but you can see. I can take one of them. This is what it happens when the cell fails. Can you see how the cell exploded? The pressure inside was too high that it melts the metal, and it basically explodes the cell. This catch fire. So that's why it's important to understand how this phenomena fails, first in a single cell, and later how it interacts once that we put more cell around it. Imagine you have your car, and in your car you have 9,000 cells like this, and one of them fails. What it will happen is it may lead to some condition like this one. And in a typical electric car, the batteries are below the seats. So just imagine what could happen there. That's a condition we don't want to reach, and we want to prevent.